Hello, everyone, and welcome to our webinar today on PCI DSS 4.0. We're glad to have you with us, and we're about to get started. Before we do, just a few short housekeeping items. We're going to have the webinar be recorded today, and so you will be able to access it later on as well, and we'll send you a link via email. Second, we're going to make this webinar very interactive. We're going to have some poll questions for you to answer during the webinar, as well as there will be your opportunity to ask questions at any time using the questions tab in the bottom right-hand corner. We'll be answering all of the questions towards the end of the webinar. At this point, I would like to turn things over to our first speaker today. Billy, over to you.
Thanks, Hormaz. I'm Billy Van Cannon. I'm the Director of Product Management here at Baffle. I've been here about a year and a half. I've been in cybersecurity for almost 20 years, and I've run public certificate authorities. I've been in identity and access management for quite a while. I've worked around compliance quite a bit with NIST and GDPR being past ones, but probably the most by far is PCI. And I'm excited to talk to you about Baffle's capabilities today. Over to you, Sushant.
Great, thank you, Billy. Hi, everyone. My name is Sushant. I run marketing for Baffle. I've been in enterprise software and cloud services for over 20 years. Worked some large companies like VMware and Cloudera, but also startups such as Baffle. So today I'm happy to talk with Billy about PCI and help you understand the changes that are coming with PCI DSS v4 and what that means for you. So let's start with an introduction. And for that, let me turn it over to Billy.
All right, thanks a lot. So yeah, we'll start out talking about a little bit of history on PCI and then v4 and converting over to that. And then we'll talk about how Baffle can help you. Let's see here. Okay. All right, so PCI DSS is a credit card industry standard. The government governs how payment card data is protected. Any organization that possesses credit card data must meet PCI DSS. And they break it down into merchants and providers, where merchants are anybody that takes credit card payments. They don't even have to be selling anything. You know, they could be like a nonprofit. But if you take credit cards, then you're considered a merchant. And then providers are people who provide services to those merchants. So great examples would be like Square or Stripe, where merchants just outsource most of that data or most of that work. But in any case, both entities need to meet PCI DSS. The merchants are divided into several levels by number of transactions. And if you're below a certain level, then you have to self-attest, meaning that you have gone through the proper self-attestation questionnaire, SAQ, and you submit that you have met all those requirements. But if you're above a given level, I think for like Visa, MasterCard, and Discover, it's above 6 million transactions a year, then you need to have a QSA to do the audit for you. And I think for Amex and for Amex anyway, it's over 2.5 million where you need a QSA. When we talk about credit card data, there's numbers of items. There's the visible things on the card, which are on the left there, your primary account number, your name, expiration date, and service code. And then on the track or in the PIN nowadays, there's additional information, which includes all that. Plus they have things like PIN blocks and verification codes. But all of this is considered card data that must be protected by PCI. There's also, if there's any additional data, they call it sensitive account data or SAD, there may be some, like when you process a payment, there may be some verification that comes back or codes that also has to be protected, which isn't on the credit card itself. PCI, they're not a government entity like a lot of them are, so there's no reporting requirements per se. And actually, most of the time when they find out they're non-compliant is when there's a breach. Most of the time, the credit card providers or the banks discover the breach before the merchants do. It's kind of easy to see why. If you think about it, if you're a merchant and your data is breached, they don't, take the cards and buy stuff at your store. They're going to go buy at other places, and they have all kinds of analytics going on that can see that, and they can triangulate it back to wherever the breach was very quickly. So most of the time, the network is going to find it before you do. It used to be in the olden days that would trigger an immediate forensic investigation. And, you figure a consultant getting paid $400 an hour for like a week's engagement, and then some travel fees here, it could be $20,000 immediately. They quit doing that a few years ago as far as the automatic breach, but if there's something that they don't like about it, they can still trigger that. They have fines that depend on, how many, your volume and how long you let it go. So if you let it go for, if it's just discovered and you fix it soon, maybe that can limit the fines, but the longer it goes, the higher they increase the fines just for the breach. And then they can also attack more on that, $50 to $90 per card. They can, once the whole situation is resolved, they can charge higher future transaction fees. And ultimately, they could even terminate your ability to take credit cards if they wanted to. And then once PCI is done, depending on your jurisdiction, depending on what happened, the government might come in with fines and lawsuits. And of course, your customers might do the same. And then what's even worse with your customers is it may cause a loss of trust and future business. Why are they moving from 4.0? Right now, they're on 3.2.1. The first thing is just keeping up with the changing landscape, right? So they have things like making passwords longer, having a little more strict rotation requirements, being more specific about multi-factor authentication. So these are all things that are just, keeping up with the best practices of security, which you have to do over time. We will talk a lot about the way you do encryption and the implications of that. So that's probably the primary thing that we will cover in this webinar. But they also want to promote security as a continuous process. And what that means is security doesn't just happen on the day that you do your audit every year, right? They want to say, they want to make sure that you're continually keeping up with your hygiene. So they have implemented within their requirements roles that need to be assigned to people. And then related to number 4 there is the way that they set up verification and reporting is based on how you do it over the year instead of just at that one time frame. Another one is they want to increase flexibility in meeting security objectives. So PCI is one of the most prescriptive security frameworks that I know of. Most of the other ones say define your assets and then assign a risk score to them, how valuable they are times the probability of being lost, that's your risk, and then assign appropriate access controls to bring the risk down. Very generically, that's the framework. But in PCI, they skip all that first part and they say credit cards. That's what we're concerned about. And here's how you're going to protect them. And what they are doing in version 4 is they're saying, okay, along with our prescription, here's our requirement. We're putting a goal of this requirement. And if you can come along and say, I can meet this goal in a different way, either because I can't do it the way PCI says, or I think I have a better way, they want to allow that flexibility so that people can innovate and, maybe even if enough people do it, they'll incorporate it into future changes in PCI. And then, as I mentioned, more verification and reporting methods. So they had updated all the way, so they do auditing within the requirements. They put more detail on, here's how we're going to ensure that you're doing this, and here's how it's going to be reported. And then they even had to go through and train all the QSAs and all the people related to doing audits. This was meant to build out, but I don't know how to build it out in the in the live stream here. But I'll try to go through this. So in the middle here, we have a timeline, 2022 to 2025, and they officially released 4.0 in Q1 of 2022. And then following that, as I mentioned before, they had to update all their documents, the self-assessment questionnaires, the report on compliance. They had to update all those to make sure that it was verified throughout the year and had more definition to it. So they soon came out after that. And then they said from that time until over here at March 31st of 2024, so just a few short days ago, you can comply to either the old version 3.2.1 or you can go ahead and comply to 4.0. And at this time, there's 13 new requirements that you had to meet by this date. That, like I said, just happened a few days ago. And then there's these future dated requirements. There's 54 of them that from now until March 31st of 2025 are only best practices, meaning this is how you should do it, but you can still be compliant to 4.0 until March 31st of 2025 without implementing them. But then after that point, they're required. So they gave, they tried to give as much flexibility and time for people to move up as they could. But one gotcha here that say your audit isn't until like Q3 of this year. And you say, oh, okay, well, I'll be best practices on those. And then I'll worry about it in Q3 of next year when my next audit comes up. Well, it doesn't work that way because in Q3 of next year, when they do their audit, they're going to say, show me how you met those requirements on March 31st. So that's a pretty significant gotcha that maybe people, hopefully have figured out by now. But I just wanted to let people know about that one. Okay, so whoops. I wanted to do a little poll here. So how much about PCI DSS 4.0 do you know, and how it impacts your data security capabilities? So the choices here are, I just started learning about it. I'm pretty knowledgeable about it and ready to make changes, or I already made changes to V4. Let me see here, actually, I have to do something. Oops. Is it shown on the screen, Hormaz? Is it?
The poll did show up on the screen.
Oh, it shows up on the screen. Okay. So yeah, if people would answer the poll here.
Billy, it looks like most people who are responding, everyone has voted, just started learning about it. So I think this is a audience that is eager and hungry to learn.
Okay, well, great. I'll go ahead and get started then. All right, so I have a page for acronyms. This is mostly for if you get this deck, without being presented, but I'll try as much as I can for every acronym to spell out what they are. And of course you can ask if you want more definition in the questions. All right, so here's the big problems we want to solve, the BAFL wants to solve for PCI DSS. And the first one here is enable encryption with no code changes and manage keys. So unless you're a true startup or maybe you're starting a new project that's greenfield, those are going to be the minority. I think most people already have an existing production environment that they have to get PCI compliant. And if you have to make changes to your code, that can be extremely difficult, especially if it's legacy code that maybe the people aren't around anymore, or if it's third-party code, it's impossible to make the changes. And then along with that, we want to be able to manage the keys for you so you don't have to write additional programs or code or systems to do that. Within PCI, like I mentioned before, that they're very prescriptive on defining the scope, their card data environment. And so they want physical and logical controls around the any credit card information. And so we'll talk about how you can use BAFL to take things out of scope so you don't have to worry about the information. The next one is data at rest. We'll talk about how PCI requires that even within the card data environment, you have to obfuscate your data. And we'll talk about some of the pros and cons of transparent data encryption, which is TDE, and full disk encryption, and how those things fit in. The next thing is data in use. And we're going to focus in on least privilege. So every security and privacy framework I'm familiar with talks about least privilege. And what that means is providing people only with the sensitive information they need to do their job and nothing else. And so that's how you can either protect the information completely in the first place, or even if somehow you get a breach, limit the blast radius, like how much information gets out. So you have to have people have to have the ability to access data, but say they get breached, like limit to only what they needed. So the first thing we'll talk about is dynamic data masking. So this is for the applications and users to only get the information that they need. And then we'll even take it a step further beyond what PCI requires and talk about how this could impact your database admin or your cloud admin for reasons beyond PCI, like you want to move to the cloud and you're worried about what liability I have in AWS or Azure as far as our data is concerned. The next one's multi-tenant. So I talked about the merchants and then the providers. It could apply to the merchants, but it's mostly going to apply to the providers. Say you're providing payment information or credit card information analytics to a lot of different merchants or even like banks, and you have to isolate that data. Now you could provide completely different physical infrastructure for everybody, but now you're going to lose all your scale. We're going to look at how you can use Baffle to do that virtually and maintain both data isolation and keep your scale. And then this last one, real queryable encryption. This is when I was interviewing with Baffle. I was like, wow, this is why I have to work at Baffle. And we'll talk about how you can continue to do analytics on that encrypted data without exposing it. All right, so the first one is encryption with no code changes and key management. And to explain how we do this, I have to dive into our architecture. So this is the basic starting point, right? You have a clear text database and you have applications. And when you're reading and writing back and forth, all in the clear, how do we get this protected? So what Baffle does is we have two major components. We have Baffle Manager, which provides a GUI and API, and it is how you do your management and configuration and auditing of all the other Baffle implementation. The next thing is Baffle Shield, which is a reverse proxy that goes between your database and your application, and it works with the SQL session layer, meaning that neither your database nor your application even needs to know it's there. So now when your application writes to the database, it goes through this proxy, encrypts to the database, and then when it reads from the database, it will decrypt it on the way out and either provide read or masked information depending on the privileges of this application. Along the way, we'll also manage the keys. So I should, I guess, stop there. Because of this architecture, you now need no application code changes. So if you have legacy code where the engineers aren't around anymore, or if it's in some language that nobody even knows how to use, it will continue to work with your legacy code and even third-party applications. So if you're out here with Power BI or Tableau and you have no access to that code, it will still work. Then the next thing is key management. So we do all the key management. We do two different, seemingly opposing aspects. One is centralized control. So we do all the mapping of the data encryption keys to the key encryption keys, and to map all that to the data in one centralized location in Baffle Manager. However, we also allow customer control in that we never actually have that key encryption key. That can be provided either by you, Baffle's customer, directly, or if you are a provider, your tenants can provide keys, the access to those keys, but the Baffle software never actually has access to that key encryption key. So this is just a little more detail here. So your data is encrypted by a data encryption key, and then that data encryption key is encrypted by a key encryption key, and you can keep that like on a semi-insecure place like an S3 bucket, but it's encrypted, so it's still safe. And then when we need it, we'll go pull that encrypted key down, go hand it over to the KMS of your choice, get that data encryption key decrypted, use it, and then delete it from memory. So that's how we provide that. It's called a two-tiered keying system or an envelope encryption. And you can tell by this PCI requirement here, 3.6.1, that they're talking about, they assume that you're using a multi-tiered encryption method like this. Like you talk about key encryption keys, and they talk about data encryption keys and how they have to be protected. I should also mention, I talked about going from version 3.2.1 to 4.0. That's the overall version of the entire set of requirements. This is actually a specific requirement, 3.6.1. And when I have these little blue and white things, I'll talk about how I'll be referring to specific requirements within the overall document. All right, so the next thing is the card data environment. So I mentioned that PCI is very specific on what's in and what's out, and then how they protect things within the card data environment. And a lot of times what you want to do is push as many things out of scope as you can. So here's where they define it. They say everything's in scope that has the card information. So here I'm showing the application, but they go further and they say any encryption method. So wherever you're doing the encryption, and so in this case, this would be Baffle Shield, or the reverse proxy I showed earlier, and anywhere the keys are. So all that has to be considered part of the card data environment, and then of course the encrypted data at rest here. So they purposely have a couple exceptions here that they talk about. One is a third-party provider. Oh, this isn't going to work, is it? Yeah, well, I can just talk about it. So basically, they say for third-party service providers, you can share data with them as long as you encrypt the data before you send it, and they have no access to the keys. That's effectively what that says. So we'll show here in a second how Baffle can do that. And then these next ones, the 653 and 655, talks about lower environments. Actually, PCI, they call it pre-production environments. Most people say lower environments. But effectively, they're development or test environments where people want data that looks like the production data, but you don't want to have your development and test environments part of PCI scope, right? That causes, not only is it a security issue, but it just causes a lot more management and headache problems. So like you want to be able to mimic that data in those lower environments, but not actually have sensitive credit card data. So here's how it works. So here's in red here, the CDE, your card data environment, and you're encrypting with Baffle, and that data is encrypted within the database. And you can set up this duplication operation. It could be like AWS DMS, or it could be even PG dump, whatever the case. However you copy the information from your production database out, and you have a firewall here with a hole in it that only allows outbound communication. And then that same encrypted data is now outside of the CDE, but as I mentioned, it's encrypted, and the keys in the encryption stays on that side. So since there's no access to the keys or the encryption tools, this can be considered out of scope. So this over here could be your business partners where you're sharing all your data, except you're encrypting, in this case, the credit card numbers and social security numbers, or it could be lower environments, so your test or dev environments. I'll also point out here, we encrypted the credit card number with something called format preserving encryption. And what that does is it preserves the data type and length of your whatever it is you're encrypting. So in this case, it still looks like a credit card. Here I'm saying it's all ones is the original data. And it still looks like a credit card, and we can even make it so it passes the loon check. So if you're not familiar with that is, it's just a verification that it's a potentially legitimate credit card. It helps prevent people from mistyping one or two letters, one or two digits. But anyway, like say your application in production is doing that check, it will still pass even though this is not a real credit card number. And then in this one, I have showing the social security number is encrypted with traditional AES encryption. The application in this case doesn't care that it looks like random numbers. But you could have also done that with FPE in case it was doing some processing. All right, data at rest. So unfortunately, I have to remember these because the animation isn't working. But 3.5.1 says that even in your credit card data environment, you must obfuscate the data. Now, they have other options besides encryption. You can truncate it, you can hash it. But we're going to talk about encryption because most of the time you're going to want it to be reversible. So this says you have to encrypt your credit card information. And then these next two talk about TDE and FDE. TDE and FDE, well, I could go through the requirements, but actually I'll come back to this since they're not defined here, and I'll just talk about what they are. So if we look at a database and we kind of break it down into its component parts, the first layer is the database software itself, right? So whether we're talking Oracle or Postgres or whatever the case may be, the actual implementation of the software. And then below the software is your operating systems. Here I got Windows and Linux, but it could also be a cloud provider, AWS or Azure, they have these hypervisors that provide access from your software to their hardware, to their infrastructure. And then there's the physical storage. So in this case, I have a hard drive here. And so if you're doing transparent data encryption, what that means is, let's see here if I can slide forward ahead. The database software is doing the encryption before it is saved to disk. And they call it transparent because it's transparent to the user. The user, is writing and reading back and forth and has no idea that the software is doing that. So that's why it's called transparent data encryption. Full disk encryption is the exact same thing, except that it's done at the operating system level. Or if like in a cloud provider, it's done in the AWS or Azure or GCP hypervisor level. But in any case, they're encrypting the data before it goes to disk. Now, this is really convenient because it's transparent to the user, as I said. But when we talk about attack vectors, it really is not providing, because it's transparent, it's not providing any additional access controls through the encryption. Now, I realize your database could have, select or what grant privileges, and you get some control there. But as far as the encryption itself, it's not providing any additional access control. The real purpose of TDE or FTE when they were invented was back, when we first had databases, there was no cloud. People had their data centers in closets in the hallway. They used to be broom closets, or they put them in the basement. And so physical theft of the hard drive was a real concern, right? You get those hard drives, you can go take it and put it in another computer and read the data right off of it. So if it's encrypted, you can't do that. And this makes a lot of sense for removable media. So like a lot of people listening probably have FDE on their laptops, because your laptop could easily be misplaced. Somebody could take the hard drive and put it in their computer. But if we're talking about modern data centers, physical theft is pretty low on the list. And I actually have a list later on. We'll talk about this. So going back, so now that we know the difference between TDE and FDE, is at least like where it's implemented, but as far as an attack vector, it's all the same. So I'll pop back here. 3.5.1.2 basically says if you're using full disk encryption, that's fine for removable media, like I said, for like your laptops and for any thumb drives, even your phones. But for fixed infrastructure, it's not adequate. That's pretty much exactly what it says. And then 3.5.1.3 takes that further and just puts more parameters on it. It says if you do use FDE, so you can use it, it's just not adequate. Here's the other things you have to have. You have to have separate keying mechanisms for all of them. You have to have those separate from the database operating system and all these other things. So it's not adequate by itself. You have to have all this additional work. Also in there, they exempt TDE, which is interesting. But I have some theories on that. So I'll pop back over here to slide 8. And actually, I'll probably move on.
Billy, just a quick question. What current SQL databases offer TDE?
Oh, okay. Yeah, that's so. So the traditional, enterprise databases that you have licensing of Oracle and Microsoft SQL Server, they have TDE with them. And then Postgres and MySQL, their open source versions do not have TDE. They might be in the works, but as of right now, they do not have transparent data encryption.
So can people use Postgres and MySQL with PCI data?
Yeah, so you can use TDE or FDE. For some reason, they are not as stringent on TDE as they are FDE. FDE, they just come around and say it's not adequate, and then TDE, they don't put those restrictions on it. But you can use anything with Postgres, MySQL, as long as you encrypt that data at rest. And most of the time, that means it has to be done outside of the database. It puts that burden on your application. So you have to write code to, whether it's in your application or separate code, or even outsource it to an API. You got to change code to work with the API, and you got to do your own key management. And so that's where Baffle comes in, right? You can, we're doing that for you, and you don't need any code changes. I will say, people, I'm sure people are saying like, well, okay, you said FDE and TDE are the same. Why are they more stringent with FDE? I think, and this is just me, I'm not part of the PCI, but right now, PCI came out in like 2006. So for the last 18 years, it's been okay to use TDE, and now they're trying to get more stringent. But it's very difficult to tell millions of people that you've already said it's okay for a long time. But those people are moving from Oracle and MySQL in pretty big numbers to the cloud. And when they move to the cloud, they're like, well, there's no reason, I'm taking advantage of this transition. I might as well move off to open source, like Postgres or MySQL, so I can avoid those licenses. And then what the cloud providers do is, it's very convenient. You set up your managed database and you can click a button that says implement FDE. So when I talk about these hypervisors, that's, AWS or Azure implementing that encryption right there. And so I think what PCI is trying to do is trying to nip it in the bud and say, okay, you got to do better than that, when you're moving from Oracle or Microsoft's server. So they're moving that way. And then I think, in the future, maybe in version 5 or version 10, eventually they'll say, okay, you got to do better than TDE as well. All right, so next thing we're trying to solve is data in use. And the first part of that is dynamic data masking. And let's see, 3.4.1 was if you're using the credit card numbers, you can only show the first 6, which is the BIN or the bank information number, and or the last 4 digits of the credit card number. But you can't show the whole card number unless somebody has a specific use case. They have to have a specific reason to know what the whole credit card number is. And then the second one, which is new to 4.0, is if you implement any remote access, again, least privileges, you have to ensure that that data cannot be copied out from the remote access and then exposed to the wrong people. So only if there's a defined reason. And so if we think about the Baffle architecture, and remember how we had the encrypted database and we had the Baffle reverse proxy in between, Baffle Shield here. In the previous pictures, I only had one application shown, but in this one, I have 3 connected to it. Of course, you could also just have 3 different clusters and have them individually connected. But however we set this up, we can make it so you can mask based on who is connected to the database. There's actually 4 different methods. 2 of them are based on the session. One of them is the session by itself. Another one is what session that role belongs to within the database. And then you can also do per user, where the application will append a specially designed comment, and it can indicate the user. And you can also connect that to an identity provider. But the main thing here is you can provide different views based on who is approaching. So human resources, we're going to say, you know what, you don't need to see the credit card number at all, so we're going to blank it completely out. But human resources needs the social security number to set up people's benefits. And then support, they don't need to have either one, the credit card number or the social security number. So what we're going to do is blank out the credit card number except for the last 4 so that they can identify who they're talking to. And the social security number, we tried that, but the application didn't like the X's. So we randomly added 2s in here, but it can show the last 4. So there's a lot of flexibility on what can be shown. And then this remote user, we're not going to show them anything because when they're connecting in remotely, they can see other things, whatever this application is doing and the other data associated that isn't confidential. But for those, we're going to protect them. And then you can also do by a specific IP address, a subnet. Here we have a CIDR notation subnet. And then here we're saying this person could be logging in from anywhere. So this is now the database is encrypted at rest, and we're providing least privilege to all these different applications. This is specifically called out in 3.4.1. All right, now this is talking about least privilege and restricting who can access what. I wanted to talk a little bit about your database admin and your cloud admin. PCI, this was just a sample. They have an entire section that talks about least privilege and how you can show credit card numbers with, like I said, their BIN, their first 6 or their last 4, but you shouldn't show all of them. And then it talks about, okay, only admins can because they have to. But I would argue that you should take it a step further and consider if your DBA should even have access to these things. So should your DBA have access to the company financials that even the CFO, or maybe only the CFO, should have? Should the DBA have access to the social security numbers that only HR should have? Or how about the credit card numbers that maybe only some people in finance should have? So what they should really say is only the business owner can access all the information, the CFO, the head of HR. And what if we want to outsource the database management? Or which is very common, is move that managed database to the cloud to save on your CapEx. But now I have to worry about my cloud admin. I think this is a big blind spot in all security and privacy frameworks because in the past, there hasn't been a good solution for it. But if we go back, we're talking about the cloud providers. Even when you go to AWS, this is their shared responsibility model, and AWS, Azure and GCP and IBM, they all have the same or very similar structure here. It says, in orange here, we're providing all the hardware and software, the infrastructure. But when it comes to the data, that's on you. And also they even talk about encryption, whether it's client side or server side. That's up to the customer to do. So when we look at that previous picture here of the encrypted database in Baffle and how we've got all the different people connecting to it and getting access with their different views, the DBA, because the database is encrypted, can go ahead and connect directly to it. They can do all the things they need to do, patch it, keep it updated, add tables, add users, the whole 9 yards. They can even grant access to the business owners. But when they try to pull the information, it's encrypted. So they do not have access to that sensitive information. And even in AWS, I actually even created an RDS instance, and I went and looked at the users, and they have service providers, service accounts in there. This is the actual exact name, RDS admin. Well, AWS has to have this access because they're managing the database for you. But if somebody did get a hold of that service account information, they still couldn't get access to your data. Now, AWS, they have a million processes and ways to ensure that people don't do that. But I'm just saying it's still not least privilege, and a lot of people still question that, despite everything AWS says. We're partners with AWS, so we trust them. But that's a big hurdle that a lot of people have to overcome. And actually, I'll talk about a customer that has that exact issue. I just wanted to kind of support what I've been saying here with this IBM cost of data breach report from 2023. And basically, they broke down how data is stolen a lot. And it's kind of tough because there's social engineering, but then there's also business email compromise and phishing, which those are subsets of social engineering. And then what are they doing when they're phishing or doing business email compromise? They're either trying to trick people into give them credentials, or they're trying to get malware, which will get trick people, say it's a keylogger, will be able to pull down credentials. So when they have those separated out from stolen or compromised credentials at 15%, I would say credentials at the heart of it is probably well over 40% of the issue. So if we go back to, if they're stolen credentials, especially if it's a DBA, the thieves have got no information. They can pull down the encrypted information. And even if they stole the support person's credentials, they can only get the last 4 in this case. So that's an example of limiting the blast radius. I mentioned that TDE and FDE are good for physical security compromise. So if somebody breaks into your headquarters and is able to steal your on-prem hard drives, maybe that's a way. The bigger one is lost or stolen device. So you leave your laptop out, and if it has FDE encryption, then it protects against it. But Baffle protects either fully if we're talking about direct database attacks, or limits the blast radius if we're talking about people who do have access. Multi-tenant. So I mentioned the providers, and let's say, this one I don't have blocked. So in the appendix of PCI, they talk about how service providers have to have these additional requirements. And one of them is logical separation. The provider can't have access to the customer's environments, and vice versa. The customers can't have access to their provider's environments. And then the next one here, the appendix A112, says that each customers can't get access to each other's. So there's the 3-way separation. So how would you do that? One way would be to just provide everybody with their own database. But the entire reason for multi-tenant or SaaS is to have scale, right? So you can have one database and put everybody's information. You add a customer, and it's literally, cents a year to add that one customer. So what Baffle does, there's two different ways we approach it. One is record level keying. So let's say you have a table, and every table represents a different customer. And over here's the application. Your tenant one logs in, or you're doing work on behalf of tenant one, and you can set up Baffle Shield such that it can reach out to wherever the end customer's KMS is. So here I got AWS KMS. Tenant 2 has a HashiCorp Vault. Tenant 3 has Azure Key Vault. We also support IBM and Google. But in case this is predefined, we go out, get the DEK, get it decrypted, and then go do whatever work we need to do on that line. And then as soon as that work is done, the DEK is erased from memory, and the next person logs in and they can do their work. So this is a great way to provide one table for all your different customers, but keep the information isolated. As a user of this application, you do not have access to the customer keys, and they don't have access to each other's keys. And if they decide one day we want to stop doing business with you, they can revoke access, and now that data is as good as shredded, which is actually, ironically, a great way to bring customers on, is to say, if you ever do leave, you can just revoke your key. Your data is no longer shredded. You don't have to worry about auditing us. They may still do it, but it's just one less thing to have to worry about. We have a customer that takes advantage. This was one of our early ones. That they do financial reporting, and they have a lot of big banks as their customers. And each of these big banks said, we're going to provide our own keys for this data. So you're going to have to figure out a way to keep it isolated. And they brought Baffle in to do that. So that was the first thing, is how do we keep all these isolated within a table? And then the second thing was, how do they provide their own key? They also, made it clear that this customer, Baffle's customer, their vendor, their DBA wouldn't have access to it. So this is a great way to prove that, even though this customer is, this entity is managing this database, they have no access to the key, so they can't get this information. And then, each one is isolated through record level keying. And then I should also mention that this was a legacy code. So the fact that they didn't require any code changes was also huge for them. They didn't have to go through and rewrite it to an API or do their own management. Another version of doing multi-tenant, but instead of rows in a table, now we have a database instance, and within that we have different logical databases. And so it's the very same idea, except for, like I said, instead of rows, it's each logical database gets their own key, but it's very much the same idea. And we have a customer that does this, and I'll talk about that after I talk about the next thing. All right, so real queryable encryption. A lot of customers, they think, well, okay, I got to pass PCI or NIST or whatever framework I need to do encryption. So they think about the first layer of how do I get the data encrypted in the database. But then comes the next problem. Say you get all your data encrypted. So up here we have this table with just some information on people, their name, age, salary, ID. And then you encrypt the information. And then somebody comes along and says, hey, I need to do some analytics. I want to do this query here. So I want to find out everybody who has a salary over $100,000, I want to get some data on that. And if you do that with unencrypted data in the database, it's going to come back with an error, because it doesn't mean anything to compare $100,000 to an encrypted set of data, and then you also can't do any math operations on their age, which is, this part. So if we go back to Baffle, and this again was supposed to build out, but we'll just kind of step through it. If the data was encrypted and you sent that query through, you would come back with an error, right? So what Baffle did was we implemented some user-defined functions. And in this case, I'm showing say an on-prem Postgres database. We implemented these user-defined functions in C and C++. And when Baffle Shield sees this query, it will break it down into functions that this can operate at. And it'll also send the key in a secure way. So this function can now pull that data into memory, perform these operations. So the first operation would be to go through all the salaries and determine which one's greater than 100,000, and then save that, and then do the math. Decrypt all the ages and do the math, and provide that back to Shield, which will then push that forward. So you get your response back, and then as soon as that operation is done, the data is dropped from memory. The data and the keys are dropped from memory. So now you're still protecting this through any normal means. Your DBA can't get this information, but you can still get these analytics. Now, I mentioned we did this, on-prem previously. One of the issues we had was that when you went to the cloud and you had a managed database, is because it was a managed database, they wouldn't allow us to implement these UDFs. Fortunately, this concept of TLE, or trusted language extensions, has been implemented in AWS, RDS, and Aurora. So what that did was it allowed us to rewrite these UDFs in Rust, which is fantastic because it's just as performant, or very close to performant as C++, but it also has memory protections. So that's even like a step further. And now, even though this is in memory, it's protected just even that much more. So you can use Baffle real queryable encryption in AWS now. It allows these server-side operations. By the way, the industry term is but it is often called privacy-enhanced computation, where you can do this. You can do these operations on encrypted data. Baffle is the only software-based solution available, and other cloud providers don't support TLE now, but we're in talks with some of them to do that.
Billy, so you mentioned AWS. What about the other cloud providers?
Right. Yeah. So I mentioned AWS a lot because we're partners, and I've been doing a lot with them. But let me see here. I'll talk about this customer here, and then I'll talk about another one that uses Azure. So, well, I should slow down. We work with AWS. We also have customers with Azure. We're also partners with IBM and GCP. So we support all of them. The question is, do they support these trusted language extensions? And like, for if you need the real queryable encryption, AWS does now. We will in the future. This is a Fortune 25 energy company. They were once one of the biggest companies around. They wanted to move from Oracle on-prem to AWS in the cloud. They wanted to, get rid of the Oracle licenses. So that was part of it. But their legal department said, yeah, we don't care what AWS says about their restrictions. We're not allowing clear text in the cloud. They're also using Tableau, which is, obviously they can't change the code of Tableau. And then they're protecting like 8,000 tables and 10 databases. So they chose Baffle because of the least privileges. We fit with the shared responsibility model in that the information is encrypted in the database. No code changes required, so Tableau worked. They even had some legacy applications as well. And it allowed the database side encryptions because we were in AWS. There's another company, a manufacturing company in the automotive industry, that had a similar situation, but they were moving to Azure. And we used our old C++. So they implemented on a VM, and it wasn't a managed database within Azure. So they implemented the database on a VM, and then we were able to implement the EDMs there. And it was a very similar situation in that, legacy applications wanted to move to the cloud and wanted all the least privileges associated with that. This is another financial institution we have, and again, it's big banks. They're doing financial auditing and compliance. They had fraud detection inspectors, so they definitely needed to do the inquiries on the encrypted data, and they wanted to provide bring your own key, or that can mean different things to different people, but in this case, it means what I've been showing with Baffle, where the customers provide their own keys for their data. So they wanted these privileges. No code changes. I think these guys even were creating new code, but like, why design your own either encryption or somebody's proprietary API when you can just make SQL queries and have it work through Baffle? And they use the logical database keys. So instead of the tables like the other customer, they used logical databases. All right, so those are the different things we talked about as far as the problems to solve. No code changes required, and we manage the keys for you. Baffle can be used to define the scope for your CDE so that your development and test engineers can get data, but not the sensitive data. We talked about how Postgres and MySQL do not provide native TDE, but even if available, you would want a more complete solution for your data at rest. Data in use, least privilege access for all users, including the DBA and cloud admin. So if you're thinking about moving to the cloud, this can be a big hurdle that you're worried about, and Baffle can help you overcome that. Logical data isolation using the either the record level keys or the database level key, logical database keys, and then real queryable encryption where you can do database side operations for your analytics. All right, and I think we'll go ahead and do one last poll here. So, do you feel prepared to comply with PCI DSS 4.0? So if you could answer that. And we'll check it out here. All right, they're coming in. It's about started out like 50-50, and now it's like 60% says no. I still have questions and research to do. Okay, so it just jumped up. It's like closer to 70% now. So okay, so that's good. I hope that I've helped you out here, and I'll go ahead and turn it over to Shishan.
Great, thanks so much, Billy. So folks, if you're interested and you want to try Baffle for PCI compliance, you can scan that QR code, or you'll see that the URL is below it. It's just baffle.io/request-a-demo PCI. You can discuss your plans to meet PCI DSS v4. You can verify Baffle's capabilities to meet your needs, and get access to Baffle. It's pretty simple. So we're going to do, looks like we have some questions, so we wanted to address them before in the last few minutes that we have. Billy, here's the first question. It says, so I can't use TDE to meet PCI v4 compliance. Why?
So you can, and it's not even as bad as, it's not as restrictive as FDE in PCI. You can use either one. It's just that you need these additional requirements on top of them. So, like I mentioned, providing restricted access where you can only see the first four or the last four. FDE and TDE won't cover that. And then when it goes into FDE, it's even more restrictive in saying that they're very outline of, you have to have your keys that are separate from the operating system. You have to have the ability to assign those keys to individual users. So you can, it's just that it requires a lot more layers than that.
Got it. Okay. Someone mentioned, I'm not sure I understand the future data requirements. Are they optional?
Yeah, so it's interesting. I think, I know that what PCI was trying to do was just make it a transition period where people had sufficient time to do it, right? But basically they're saying on March 31st of this year, a few days ago, there's these 13 requirements that are different from 3.2.1 that you have to meet. And then there's these other 50 some requirements that it's only best practices until March 31st of next year, at which time then you have to be, they're required that you meet those. And I mentioned there's that one gotcha is if your assessment is in Q3 of this year, don't think, well, don't have to worry until they assess me next year. Next year at Q3, they're going to say, show me how you were compliant on March 31st of 2025. So, or of 2025. So,
okay. Here's another one. What am I on the hook for when I use a third party to process my credit card transactions?
Yeah, I think a lot of people may think, well, I don't have to worry about it. I Stripe or Square or whoever does my credit cards. You are still responsible for PCI DSS. It's just you've done a good job of pushing a lot of the responsibility on to somebody else, but you still have to go fill out. If you're not a level 1 merchant, the SAQ that says you do this. You still talk about how you got to protect your website if you're taking it in through the website, or you got to protect the actual reader if you're at a brick and mortar store. So there's still, no matter how much you outsource, you're still responsible for the credit card information. And if Stripe gets breached, heaven forbid, you're still on the hook. Then both of you are on the hook. So PCI doesn't allow anybody to skirt under it by outsourcing.
All right. Looks like we have time for one more question. You mentioned there are other forms of privacy-enhanced computing, which you call real queryable encryption. What are they?
Oh, yeah. So we call it real queryable encryption because there's a database provider out there that calls their encrypted database queryable, but it really means exact matches, and you can't do the advanced sort, search, or math database side operations. There are other techniques. There's one called homomorphic encryption. There's another one called SMPC, which is secure multi-party encryption. Both of those can do processing on the encrypted data directly, but they are very complicated and they slow down operations by literally orders of magnitude. And so one thing I know in dealing with people who set up databases is performance is a big issue. So that is, even though their software is still a ways out, if ever is possible. And then there's another way you can do it with hardware, where they're called secure enclaves. The problem with that is, the hardware is going to be more expensive. You're going to be locked into that hardware, and it doesn't scale easily. Like you can't take the data and break it up and very easily, spread it over a bunch of different pieces of hardware. Whereas Baffle, we're a container. You can scale this up vertically and just use a huge, single server if you want to, or you can scale it horizontally, start off small, and then as your needs grow, just add more containers to your cluster.
All right. So it looks like there's more questions, but we're about out of time. So let me turn it over to Harmaz for the final housekeeping.
Okay, well, hey, listen, thank you everybody for joining us today. We hope this was useful. I would like to thank Billy and Sushant, our speakers, as well, for the great information. And as mentioned before, look for an email later today with the link to your recording. And you can also reach out to us if you would like to schedule a time to speak with us more about this in person. We hope you all enjoyed this webinar, and we hope to see you on the next one. Thanks, everybody. Have a good day.
Thank you.